Hi folks, Dr. P here. This is question 16 from the probability assignment. Johan is planning a weekend trip. He's considering cancelling the trip if the weather is wet. The probability of a wet day is 0.3 and the weather on each day is independent of the weather on the other days. So we have a partial tree diagram here. And in question A, complete the tree diagram to determine the probability that both days will be wet and there will be only one wet day. All right. So here we are using the notation W for wet. So W1 means that the first day will be wet and the probability of that occurring is 0.3. W2 means the probability that the second day will be wet, and the probability there is also 0.3 because they're independent events. Okay. Now, the probability of day 2 not being wet would be 1 minus 0.3. Okay, because they're complementary events. It's either wet or not. So 1 minus 0.3 is 0.7. Okay. Day 1 can either be wet with that probability 0.3 or not wet with the probability of 0.7. And finally, if the first day is not wet, if we go down this branch in this tree diagram, the second day can either be wet or not wet. The probability of it being wet is 0.3 and the probability of it not being wet is 0.7. Okay. And then, so we have a number of outcomes here, so we can actually write down all of the outcomes. They're not asking for that, but it could still be useful down the road here. So for if you go down, if the first day is wet and the second day is wet, and the probability of having a wet day 1, wet day 2 is simply going to be 0.3 times 0.3 equals 0.09. The probability of the first day being wet and the second day not being wet would be 0.3 times 0.7, which is 0.21. The probability of the first day not being wet and the second day being wet is 0.7 times 0.3, which is 0.21. And then finally, the probability that the first day is not wet and the second day is also not wet is going to be 0.7 times 0.7, which equals to 0.49. Okay. So now if we look at this first question here, the probability that both days will be wet. So that's probability of day 1 being wet and day 2 being wet. Well, we already have that. It's right up here. It's 0.09. The second question here, there will be only one wet day. Well, there are two scenarios there. It could either be this one where the first day is dry or not wet, the second one is wet, or this one here where the first day is wet and the second one is not wet. So we would write the probability is for the first day being wet, second day not being wet, and it's a union, the first day being not wet, that's a not wet there, right? Times and the second day being wet, right? So that's simply going to be 0.21 plus 0.21, all right? Because it's either this, or basically means addition, which is 0.42. He decides to cancel the trip unless the odds of 2 dry days are better than evens. Should he cancel the trip? So the odds, the term odds here could be a little bit confusing. We're not talking about odds ratios, we're talking about the probability here. Okay, and we're talking about if the probability is less than 50% of 2 dry days, then he should cancel the trip. Okay, so the probability of 2 dry days, or not wet days, day 1 would have to be not wet, day 2 would also have to be not wet. Well, we know that probability is right down here, is 0.49. Okay, 0.49 is less than 50%, or the probability is 0.5. Okay, so that means that he should cancel the trip, although it's right on the edge there, right? But yeah, hope that helps.